Okay, this time I promise I won't talk past 10 minutes. I promise. Okay, so this is another interesting little Punnett Square heredity type lesson, and we're going to be dealing with codominance, bang, codominance, and something kind of similar in just a moment called incomplete dominance. Now, both of these terms, codominance and incomplete dominance, are exceptions to the rule. So some of the basic, Mendel dominant and recessiveness types of ideologies are going to change. So here, instead of having one trait that's dominant over another, or of course one that's recessive to another, now we're going to see some sharing taking place. So the first term is codominance. That's what you see here. And just to be super duper clear, these are both exceptions to the rule, and thus they are kind of rare. So for my example of codominance, we're going to look at something that occurs sometimes with dogs. Okay, take labs, for example. I used to have a black lab, and I'll talk about my black lab in just a moment as I get through this example. Okay, so here we go. I'm talking too much already. So let's just say I have a black dog. Okay, the gene or allele for black fur color, we could say we can give it a B. Okay, we could also just as easily say W. Okay, because they are codominant. One is not dominant over the other. Wrap your brain around that. Yes, it might be confusing, but one is not dominant over the other. They share. Hence that nice little prefix co. So let's just suppose we have a homozygous black dog. So we're not going to say homozygous dominant because it's not dominant, nor is it recessive. It's just homozygous. All right. So we have a homozygous black dog, and this dog is going to mate with a homozygous white dog. Okay. So like I was trying to say just a moment ago, I could have said this black dog is big B, or little w, little w. Okay. And similarly, the white dog we could say is capital W, or little b. It doesn't matter. The only thing that matters is that you're consistent. So I can't say, big B, big W, or whatever. I have to be consistent with both of my variables. Okay? So either way is fine, just not big B, big W. So we're going to say, in this case, we're going to say B because I wrote the word black first. Okay? So let's take our black dog, big B, and once again, it mates with a homozygous white dog, and we'll just say little b, like I explained, hopefully clear enough a few seconds ago. Let's do the math. Bada boom, bada bing. You can see that all four of these possibilities are big B, little b. So in the old way of learning things, we would have learned that one trait is dominant over the other, but guess what? That is not the case. So my phenotypic ratio is still 4-0, but, oh, that's a big but there, but 100% of these dogs will have spots. Bam! New learning has taken place. 100% of those dogs will have spots. So I was talking about my black Labrador Retriever way back when I was a younger dude. Her name was Midnight. Yes, she was a black lab, but on her chest and on her belly, she had white spots. So what does that mean? Does that mean she was a purebred black lab? No. My poor Midnight was, a little bit of a mutt, and that's okay to be a little bit of a mutt. No worries at all about it. Okay, so the white dog and the black dog gives you dogs with spots. Whether it's a white dog with black spots or a black dog with white spots, it doesn't matter. There is some combination of spots taking place. Let's do another one. Why are we going to do another one? First off, I want you to learn it, but secondly, this is pretty fun. All right, I'm not sure if that was even correct grammar, but what the heck, this is fun. Here we go. So let's take dogs with spots, like my Midnight with her, predominantly black coat, but her white spots on her belly and chest. Let's take the two spotted dogs, black and white. Let's do the math. You've seen this at least a million times. I mean, if you can't do this, come for tutoring. All right, so let's take a look at this genotypic and phenotypic ratio. This right here, all weird things are happening. The phenotypic ratio is 1 to 2 to 1. And you're like, huh? Why 1 to 2 to 1? You might be asking. Well, take a look at what I wrote here. It used to be, if it starts with a capital B, the dominant trait's expressed. But what have I said like at least 14,000 times? There is no dominant trait because they're codominant. So we've got one dog that is black. Okay, that's this old gal or girl or boy or whatever right there. And then we've got 2 dogs that are spotted. Okay, the 2 heterozygotes now have a different phenotype than the pure or homozygous black dog. And then the little b, that would be the white dog. Okay, does that make sense? So like I wrote down there with my neatest handwriting possible, the genotypic and phenotypic ratios will always be the same in examples of codominance. Now, incomplete dominance. Take a look here. Instead of having both traits or alleles or genes or whatever nice funny word you want to use, instead of having them expressed like white and black spots on a dog, in this case you get a blending. So if we were to use this previous example, of course this was a real life example, guys, this is real life, but if we said it was incomplete dominance, instead of having a dog with spots, you'd have a gray dog. Does that make sense? But just to be crystal clear, if it was a test problem, I will tell you in the problem that this is an example of codominance, or this is an example of incomplete dominance. If I don't use any of those terms in the test problem, then just work it out like a regular old Punnett square, where there is a trait that's dominant or a trait that's recessive. Okay, so codominance, dog with spots. If I told you incomplete dominance, the heterozygotes would be gray. So that leads me to my next example. Incomplete dominance is where there is a blending. So you don't see this as often with animals, but I'll give you a great example with salvias. In my flower bed over here, I have a whole slew of scarlet sage. Sometimes they're also called Texas sage. It's Salvia coccinea. That's the scientific name. Bang, I could rattle off probably like 1,000 scientific names, but whatever. What stinks is mine are all red. Okay, they're all red, but here's the deal. So I'm gonna label big R for red, and we'll say little r is white, but it is an incomplete dominant type of example. That means there's a blending. So I just as easily could have said, if you look what I wrote here, we could have said white, give white the big dominant W, and give red the little w. And of course I wrote it in cursive so we don't get confused with capital and lowercase and whatnot. But I wrote big R first, so just like I did in the previous problem, the one I wrote down first, we'll just work it out as is. So 2 heterozygotes. Oh, by the way, if they're heterozygotes, what color should they be? They should be, bang, pink. Yeah, you can tell the coffee has been kicking in, boys. That is pink. So we got big R, there you go, that one. Big R, little r, and then the 2 white ones at the end, little r. So same thing here. Pay attention to that phenotypic ratio. In incomplete dominance, just like, what do we say? Just like with codominance, I wrote it down for dramatic effect. The phenotypic and genotypic ratios are always the same 100% of the time. So let's take a look at what we have. We're gonna have, if I have the 2 heterozygotes or the 2 pink flowers cross-pollinating and hooking up and doing natural things like flowers do and whatever. You get what I'm saying? Yeah, you get what I'm saying. The big R is red, big R, little r is pink. That's like the parents. And then the white, hence my 1 to 2 to 1 ratio. And what would have been really cool for like the millionth time is if I had red ones and white ones and pink ones to show off, but alas, I do not. And I'm done. I kept it under 10 minutes. Peace out, boys.